Okay, we'll see the next topic, that is Wheatstone's bridge. Okay, so in this Wheatstone's bridge we are going to use the Kirchhoff's second rule as well as junction rule. Kirchhoff's first rule is said to be junction rule and Kirchhoff's second rule is said to be loop rule. Okay, both rules in our last video we saw. So that concept we are going to apply here. I will tell you what is meant by bridge balance condition in Wheatstone's bridge. See here, Wheatstone bridge is an arrangement of 4 resistors like this. Okay, see here, this is a resistor R1, R2, R3 and R4. 4 resistors are arranged like this. Okay, and this is a junction point. See here, and I am going to give name for these corners A, B, C, D. Okay, here BD is a galvanometer arm because between B and D we are connecting a galvanometer here, and A and C we are connecting a cell here. Okay, or battery here. So AC is said to be battery arm. So you remember Wheatstone bridge contain how many resistors? 4 resistors. R1, R2, R3, R4 are arranged like this, and between B and D we connect a galvanometer, A and C connect a cell. So this is the Wheatstone bridge. Now I will tell you what is meant by bridge balance condition in Wheatstone's bridge. So see here, if R1 by R2 is equal to R3 by R4, that is ratio of R1 by R2, which is equal to ratio of R3 and R4 means then the bridge is said to be balanced. What is mean by balanced? IG means the current flows through the galvanometer. Okay, that is equal to 0. No current flows through the galvanometer. Galvanometer shows null deflection. Null deflection அப்படினா zero deflection அர்த்தம். Generally உங்களுக்கு தெரியும் ஏற்கனவே galvanometer is a device which is used to detect the current in the circuit. Okay, so when the current flows through the galvanometer shows deflection. But if the ratio of R1 by R2 is equal to R3 by R4, ratios are equal means that time no current flows through the galvanometer. The current flows through the galvanometer, Ig is equal to 0. So galvanometer shows null deflection. When no current flows through the galvanometer, because the potential at B is equal to potential at D. Okay, so that is the main concept. If there is a difference in potential between the 2 points, then only the current can flow. But there is no difference in potential. Both points are at the same potential means that time no current flows through the galvanometer. So, anala bridge balance condition nale the resistors noda ratios வந்து equal இருக்கணும். அதனா வந்து Wheatstone bridge balance condition சொல்லுவோம். Okay, so using this இப்ப நமக்கு வந்து we are going to prove this. Okay, so how to prove this? Before that you should remember every galvanometer also offer a small resistance to the current flow. That resistance is considered as Rg here. So what is Rg? R and suffix G. It is nothing but resistance of the galvanometer. So remember that resistance of the galvanometer is denoted by the letter Rg. Okay. So see here, the ends A and C are connected with the cell, no? So what current will entering into the junction A? That is current I. I am going to use the current rule for every junctions now. So listen carefully. So this is the junction A. What is the current entering into the junction? That is I. So that I is split into 2 parts and current leaving from the junction. See here, if we consider the current flows through R1 is considered as I1. Means what is the current flows through R3? I1 current enter ஆகுது. I1 இங்க போயிடுச்சுனா இந்த current definitely என்னவா இருக்கும்? I minus I1. Okay, already in the case of current law I told you the sum of the current meeting at a junction is equal to 0 or sum of the current entering into the junction is equal to the sum of the current leaving from the junction. So, this I and current for example, so 10 ampere current or junction towards in the current 6 ampere definitely in the current 10 minus 6 ampere that is equal to 4 ampere. So the same rule here we use. I is the current entering into the junction. I1 is the current flows through R1 means definitely the current flows through R3 is I minus I1. Are you clear? So that's all. See here. At the junction B, the current is split again into 2. So see, the current flows through the galvanometer is said to be Ig. Now, enter current I1. Okay, so I1 current enter and the current Ig current flow the galvanometer. But definitely this current will be I1 minus Ig. Okay, the same rule here also we are using. So I1 is the current entering into the junction B. This is the current flows through the galvanometer that is denoted by the letter Ig means the current flows through R2 is said to be I1 minus Ig. Okay, here. So what is the current come out from the galvanometer? The same current, that is Ig. So see here it is nothing but I minus I1. So both currents entering into the junction. So this is the current leaving from the junction. So sum of these two value will be the current flow through R4. So see here I minus I1, this is the current here, plus Ig will be the current flows through R4. So total value. Okay. So I explained you what are the current flows through every arm. With the help of the junction rule, we wrote all the things. So this is the current I1. I1 minus I2 will flow through R3. What is the current flows through I4? I minus I1 plus Ig. And what is the current flows through the galvanometer? That is Ig. What is the current flows through R1? That is I1. What is the current flows through R2? It is I1 minus Ig. So here the total current, the current entering into the junction A will be the current leaving from the junction C. Okay, so now we are going to prove that bridge balance condition. So what is the bridge balance condition? The ratio of R1, R2 is equal to R3, R4 means the bridge is said to be balanced. The current flows through the galvanometer is equal to 0. So see here, consider the loop A, B, D, A. Now we are going to use the loop rule. Already we used the current rule and we calculate the values of current flow through each and every resistors present in this circuit. So now I am going to use the loop rule for the loop A, B, D, A. See here, A, B, D, A. This is the first loop we are considering. First step what we have to remember, we should remember the we should assume the direction here. So here we are going to assume the direction as clockwise direction. So in the arrow mark so clockwise direction current eppadi pogudu nam assume panikrona A, B, D, A direction la current flow agudhu nam assume panikrom. So see here in this loop there is no cell or battery is there. So what is the EMF in algebraic sum of the EMF? That is 0. Nama consider pandra loop la cell or battery edume illana EMF irukra edathila we should substitute 0. So 0 is equal to, now product of the resistances and current we have to remember. So see here, what is the product of resistance and current here? R1 into I1 here. So here the product of Ig, current is Ig and resistance of the galvanometer is Rg. So Ig, Rg here. Here that is R3 into I minus I1. R3 into I minus I1. So you remember the sign that is positive or negative here. So see here the current direction through R1 is same as that of our assumed direction. Nama assume panna direction current flows through R1 same. So positive I1 R1 is positive. Next one IG, RG also positive because நம்மளோட assumed direction actual direction same. But here consider this here our assumed direction is from D to A, but actual direction is A to D, so that is taken as negative here. So minus I1 into R3. Okay, so this is the equation formed for the loop ABDA. Similarly, see here loop BCDB. See here BCDB. Okay, here also I am considering, I am assuming the direction as clockwise. So no battery or cell is here. So EMF is 0, which is equal to, see here, R2 into I1 minus IG. Okay, next one R4 into I minus I1 plus IG. Here RG into IG. Okay, IG into RG. So sign we have to remember. இது மட்டும் தான் வந்து clockwise. நம்ம கன்சிடர் பண்ண assumed direction actual direction இதுல மட்டும் தான் பாசிட்டிவ். So இதுவுமே வந்து anti clockwise. Here also that is anti clockwise. நம்மளோட லூப்ல நம்ம கன்சிடர் பண்ணிருக்கிறது, நம்ம அஸ்யூம் பண்ணிருக்க டைரக்ஷன் clockwise. ஆனா இதுல இருக்கிற டைரக்ஷன் வந்து ஆப்போசிட்டா இருக்கனால the minus symbol is used here and here. Okay, so see here. So now assume IG is equal to 0. What is IG is equal? What is the meaning for IG is equal to 0? The current flows through the galvanometer is equal to 0. The galvanometer shows null deflection. அப்படின்னு நம்ம assume பண்ணிக்கிறோம். இப்படி assume பண்ணிட்டோம்னா in equation number 1 லையும் equation number 2 லையும் IG is equal to 0 னு substitute பண்றோம். So see here IG 0 நீங்க substitute பண்ணோம்னா இந்த term full 0 ஆயிடும். So we'll get this equation like this. I1 R1 minus I minus R1 into R3 is equal to 0. So இதை equal symbolக்கு அந்த பக்கம் கொண்டு வந்தோம்னா equal to இது is equation number 3. So see here rearranging this term. So equal symbolக்கு இந்த பக்கம் வரும்போது minus positive ஆயிடுது. This is the equation number 3. So substitute this value of IG is equal to 0 in equation number 2. So இங்க IG 0 னு substitute பண்ணோம்னா this equation becomes, see here, this is R2 from equation 2 R2 I1, R2 I1, this becomes 0. See here IG 0 na minus I minus I1 into R4. This full term becomes 0. So see here rearranging this equation will get an equation like this. This is considered as equation number 4. So now divide the equation number 3 by 4. So like this will divide. So I1 gets cancelled. So நம்ம இப்ப என்ன பண்றோம், equation number 3 and equation number 4 ஆல divide பண்ணிருக்கோம். So I1 gets cancelled. I minus I1 by I minus I1 gets cancelled. So we'll get the equation like this. R1 by R2 is equal to R3 by R4. So this is the bridge balance condition. Already we told if R1 by R2 is equal to R3 by R4, the galvanometer shows null deflection. So galvanometer null deflection காட்டுதுன்னு எடுத்துட்டு ratio calculate பண்ணா we get the ratio as what we said. So thus proved. This is said to be Wheatstone's bridge balance condition. So what is the use of this bridge balance condition? So this is the basic principle of next devices, meter bridge and potentiometer. Especially those two devices are more sensitive and more accurate devices. We'll discuss in the next video. Now I am going to explain a small problem which is related to Wheatstone's bridge. So Wheatstone bridge is a very important concept, especially for problem part. Okay, so see here, this is the problem. Check whether this bridge is balanced or not. Calculate the current flows through the galvanometer. That is the question. So மாதிரி ஒரு circuit கொடுத்துட்டு இந்த bridge வந்து balanced இருக்கான்னு check பண்ணுங்க. Calculate the current flows through the galvanometer is the question. Okay, so see here, what is our bridge balance condition? That is R1 by R2 is equal to R3 by R4. So we have to check the values. R1 is here 6 ohm, R2 is here 3 ohm, R3 is here 12 ohm and R4 is here 6 ohm. So cancel out பண்ணோம்னா 2, here also 2. So this bridge is a balanced bridge. So galvanometer shows null deflection, no current flows through it. Okay, so see here, இப்போ இதுதான் வந்து இது bridge balance condition check பண்ணுங்க, current calculate பண்ணுங்க. Galvanometer null deflection காட்டுனா what is the current flows through the galvanometer? Nothing but 0. No current flows through the galvanometer. So galvanometer current is equal to 0 in that case. One more sum I will do. So இதே sum இப்போ நம்ம வந்து இந்த சென்டர்ல ஏதாவது ஒரு ரெசிஸ்டரை கனெக்ட் பண்ற மாதிரி நமக்கு கொடுத்துட்டு calculate the net resistance between the two points A and B னு கொடுத்திருப்பாங்க. Okay, so see here, so this is 4 ohm, this is 2 ohm, this is 8 ohm and this is 4 ohm. Okay, so இந்த இடத்துல வந்து ஒரு 5 ohm கொடுத்திருக்காங்க and calculate the net resistance between A and B அப்படினு கொடுத்திருக்காங்கன்னா we can say this is a bridge balance condition. 4 by 2 is equal to 8 by 4. So definitely we can say this is a balanced Wheatstone bridge. So this resistor is meaningless. No current will flow through it. So we can neglect this resistor. So again, how to calculate the net resistance? These two are connected in series. These two are connected in series. So this can be simplified as this is nothing but 6 ohm and this is nothing but 12 ohm. Okay, both are connected in parallel connection. So what formula we have to use? 1 by Rp, or simply Rp is equal to R1 R2 by R1 plus R2 formula we can use. So see here, 6 into 12 by 6 plus 12 will give the net resistance. Okay, so you should remember எந்த மாதிரி எந்த circuit கொடுத்தாலும் அது Wheatstone bridge balance condition க்கு வருதான்னு check பண்ணிட்டு then easily we can simplify the circuit and we can calculate the net resistance. The same concept will be used for capacitors also. இது மாதிரி 5 capacitors கொடுத்துட்டு அதோட ratios வந்து equal இருந்துச்சுன்னா that time also that is said to be Wheatstone bridge balance condition. I will teach you one problem like that later in the next video or later. Okay, thank you.